Hi everyone, I'm very glad to be with you tonight, and we will speak about how we can estimate some carbon emission from a company using machine learning. So first of all, we will speak about the context, about the current state of the art in this topic, and also about our methodology in regard with what is done already, and I will share with you some first results and the next step with some news. First, about the rationale and the context. We all know about the different way to calculate those GHG emission in general and the carbon equivalent. So the first one is the scope 1, which are the direct emission, which are the company facilities and the company vehicles. For these ones, the larger issue that we have in terms of sectors are in the energy and utilities, of course, but also materials and transportation sectors. For scope 2, it's indirect as well as the scope 3, and we will focus on the scope 2 today, not on the scope 3. But for the scope 2, it's the indirect emission that are linked to the energy purchase, electricity, steam, heating for the own use of the company. And for those, we still see the materials, but we have also the food and staples and telco, and of course energy that are the main contributor of the scope 2. For the scope 3, I will speak a little bit at the end about the scope 3, but I think it's important to keep in mind that most of the total GHG emission are coming from the scope 3, but you have a lot of double counting. It's a bit more complex, as you can see. Everybody knows about the business travel and the commuting from the employee. But it's a bit more complex, and you don't have really a standard from the company that are reporting the scope 3 emissions. So just something to mention also, it's important to know that it's not only about CO2, it's about all the greenhouse gas that are emitted by the companies. And we are focusing on CO2, CH4, but there are more, they are on the top right of the slide. Now, in terms of where do we stand in the market, if you look at who is reporting the data and who is not, if you look at the large market cap, so let's say around 3,000 issuers, most of them, about half of them, will be reporting the scope 1 and 2 emission at least. Scope 3, it's a little bit less. Then if you go to something that is a bit more global, let's say the global Bloomberg universe or our global universe, which is more than 10,000 issuers, you have roughly speaking about 20% of the companies that are disclosing the scope 1 and 2 with a good quality. For the rest of the universe, it's based on some estimates. So it's 80% of the data that is estimated with models. The scope 3 is not well reported, as I was saying before. I will speak a little bit if we have time at the end about scope 3. We are working on that. We have some results. It's not part of this presentation. It will be part of another presentation and paper. About something also important to mention is that if you look from 2010 to now, you don't have a huge increase of those reporting of the carbon data, which means that even if we have some new regulation nowadays that will improve the overall coverage of the company disclosing the carbon, we don't expect that the quality and the standardization will rise in the next 1 or 2 years. So we will probably continue to have a few companies among those 15,000 from our universe that will disclose, and a lot of the other companies where we would need some model to estimate their future carbon emissions in terms of what they can assess by themselves and disclose. Now about where we stand about those models and how it's possible to estimate those carbon or GHG emissions. Just to measure the model and to compare the model, we believe it's important to have different objective measurements of the quality of the model. What we call in the sample is just the capability of a model to reproduce some numbers that we know already. So let's say you have a sample where you know the scope 1 and 2 of the companies, or even one scope of the company, you're going to hide to the model a part of the sample, and you will ask him to assess the hidden part. What we do in general is that we split the sample in 10 or 3, and then you train the model on a 10 or a third of the sample, and you try to estimate what is the result where we have the data, and we compare the data with the real data. So we compare the model prediction to the real data. For that, we use R2. Most of the time, it's R2 log. We give you the formula here. It's nothing strange. We just compare the distance between the two. So that's what we call in the sample. And then you have another measurement, which is out of the sample. So that's where we don't know anything. Nobody is able to have a real data coming from the company or from CDP. And then we compare what are the different estimates from the different companies. The idea there is to say, if I am doing some estimates on a company that nobody knows about, if I am very far away from the other estimates, it's not a good sign. So we compare to Trucost and to Bloomberg over roughly 8,000 companies. We were able to compare our result to the result of the two competitor models. Now, in terms of the metrics that we observe, we use here a publication from Nguyen and Diaz-Reynés, where they had compared those models. And you can see that, roughly speaking, you are between 60 and 80% of R2 log over the models. And something important is that you have the naive mean estimation type of model, and then you have the statistical, what we call empirical estimation here. The naive mean estimation, it's something very easy to do. It's basically you say, okay, I have a sector. You can define a sector very specifically, even going to GX2 or 3 or 4 level. And then you say, for a certain metric, for example, revenue or number of employees, if you have a company in the same sector where you know the data, and you have another one where you divide by 2 the revenue, or you divide by 2 the number of employee, you would assess that you divide by 2 also the scope 1 emission, for example, or scope 2. So that's kind of extrapolation of what already exists in terms of disclosing of carbon emission. It shows some R2 square, R square score that are roughly 60%, which is enough to use something, but we don't believe it's enough to make investment on that, because it's going to change from a year to another one. Then you have the empirical estimate. Here you have the CDP statistical model, which is one of the most used, and CDP, everybody know about the quality of their work they are doing. The number of observations they had was 2,500 roughly, and the result they had was between 80 and 86%, which is a good score. We will compare after to others. Then you have some others models that were used with always less than 2,000 observations. So just to give you a number also, in our model, we have 16,000 observations. So if you have a nice R2 square log using a model where you have more observation, it means that the quality of the model is also better, because you had a huge universe to compare. So it's always about, it's what we call in the sample. It's about comparing how the model can assess the reality that you already measure. And what you will see here is that you don't have a lot of data points. And also the numbers that you reach in terms of R2 log is roughly, in the best case, around 80–85%. Now, about our methodology and the carbon project methodology that we are using, it's completely different approach. Like, we don't assess for one industry the carbon emission or GHG emission and then extrapolate. One of the issues you could have in the traditional approach is that sometimes you have in this industry where you don't have any data point, and then you have to go to the upper level. So for example, if you have a waste management utility, if you don't have any data point about GHG emission, you will have to go to utility, which is completely different, because you would have electric utilities and different things that are of course, having more GHG emissions. In our approach, what we do is that we have a full data set where we put some features that we think are important to predict the carbon emissions. And overall, if you don't have data points in one industry, the model will handle by itself the missing data points. And also, every time you correct one data in our approach, it's also improving the model overall. It's not only for one industry at G3 level that if you correct the data, you have only the improvement for this level. It's a full integrated approach. Also, what we think is important is that you have some data that we will speak in the next slide that doesn't look like important at the sector level because it's some geographical information. You have a lot of different type of information that are together improving the quality of the model. So about those predictors that we were discussing, you can say that you have three different types. You have some regional predictors, you have some company-specific predictors, and you have some industry classification predictors. In terms of regional predictors, what I think is important is to know that, yes, if there is a tax in the country, and you have a lot of publication that already show that kind of result, if you have a tax scheme in a country, you will see that you have some improvement, and it changed the way a company is spending and emitting carbon or GHG gas. Also, for that, we use the World Bank or the International Energy Agency data, which is something that is for free. So it's interesting to see that you can share then the data. Then we have some company-specific predictors. There are not a lot of them. I think it's around 8 or 10. And basically, it's some kind of revenue data that you have from a company, number of employees. So it's roughly speaking the size, the quality of the asset size, and the profitability from the financial statement. And it's everything coming from the financial statement. So it's nothing. It's everything for free and everything also public. Then you have some industry classification predictors. What we want to have is a good definition of the business model of the company. So we use the GX 1, 2, 3, 4. You could use also some other type of industry classification. The idea is to have a little bit like the traditional approach, some kind of definition of business type. And then we say that for a certain business in a certain country, for a certain size, for different type of asset, then you have some kind of linear combination, but not only, you will see that in the next slides, that can explain the final estimates. For that, we use also the training sample, and for the training sample, we use the carbon footprints for scope 1 and 2, for that, we use the exact emission data. So we don't use the estimates from other competitors, we just use the carbon data from CDP or that are reported by the companies. Now, I was explaining that you can have different type of regression, of course. So we split the model in two different types, the linear regression models and the non-linear regression models. What we decided is to use an elastic net linear regression model. One of the reasons is that it's kind of easy to explain then to some clients the results. So you can say, okay, this country by minimum would be like, I don't know, one ton of CO2 equivalent. And then if you are in this company, in this sector, you have, I don't know, 5 more. And then you have a linear combination of revenue, employees, total assets, age of the asset, these kind of things. But you can explain with a very simple formula that you have a constant plus something. The constant could be negative as well, to assess the overall GHG emission for the scope 1 or scope 2. Things is that it's not completely accurate for some of the companies, especially the big ones where we are interested in. And so we also use a non-linear regression model. For that, we use an extremely an extra tree model, which is kind of a more general version of a random forest to have more freedom to leave more freedom in the model to find some patterns that are not in the linear model. The problem with that is that it's a bit more complex to explain to a client. It looks like a little bit like a black box, but it's also good because it's more accurate if we see the numbers in terms of air-to-log. The stability is good for both of them, so there were no constraint with the stability. And then, of course, the question is like, which number you're gonna keep at the end. So for the reason of the regulatory constraints and to stay a little bit more conservative, we decided to use the max between the two. And as by construction, by doing this, we still have the linear regression model that are very usable and easy to use for a client to explain numbers. So you could have a nonlinear regression model result that is a bit different from the linear regression model, but you can still explain the linear parts to the client. Now, in terms of results, what we see here is the result we had a few months ago. We are still improving the model and we are still working also on scope 3, and I will speak a little bit about that. What we could see is that for scope 1, basically you have 3 or 4 sectors that are responsible for everything in scope 1. So that's what we were explaining at the beginning. So if you are able to assess quality with a good quality, the utilities, the materials, energy, and the transportation sectors, then you can assess globally scope 1 very nicely. But of course, we have portfolios with different type of investment and sectors. So we are happy to have air-to-log that is correct for all the sectors. If we would have a very bad score in one sector, it will also destroy the quality of the overall model because it will create some kind of bias for the investment. So if you look at the quality of the model in terms of in the sample, how the model is able to reproduce, I don't know if you remember, but here we have 17,000 points from 2011 to 2018, which is by far more than what you can see in the literature, in the scientific literature and papers that are working on that. And on the right, that's the out of the sample, and you could see that the green dot, that are the BNP dot estimates, are by far much more in the middle, which means that when we have estimates, we are between the true cost estimates and the Bloomberg estimates, which is some kind of reducing the model risk if you take the Ramakrishnan definition. And I think it's important to know that we don't know, and you can have a discrepancy by a factor of 10 or 100 very easily in the scope 1 or even in scope 2. So just to say we are in the middle of other estimates looks to be a good indication of the quality of our model. Now, in terms of scope 2, you see that it's a little bit the same story, but a big difference in the scope 2 is that you have more sectors that you need to model with a nice quality to have a good overall model, because you need to go to banks, transportation, consumer durable apparel to reach the 95% of the total sum of the emissions. Meaning that here you can see that on average we have a more than 70% or 75%, but also the minimum is quite high. We don't have anything below 67 for the utilities, and we have improved these numbers since the time we prepared the slides. It's the same thing, and one thing to also compare is that we have 8,000 companies, roughly speaking, where we compare the data, which means that overall you could imagine that for 10,000 companies, you are able to say that we can reproduce the data, the sample data for the scope 1 and scope 2, and the good quality sample. And for where we don't have any type of quality information, we stand in the middle of two other competitors. Something is that it was much more easy, of course, to compare to two competitors. At the time, we had 2 of them. Nowadays, for scope 3, it's a bit more complex because nobody wants to estimate the scope 3. So we are working on that. For the in the sample part, we reached something like 70% of air-to-log, which is already good. So we are able to reproduce what the company are disclosing in terms of scope 3. But we would like to continue working on that and to improve the quality of the model to show that we are also able to assess in a better way the company where we don't have any type of information about the scope 3. I think it's all for today. If you have some question, I'll be happy to read them and to answer them in the log. If you want to continue, you can also reach me on LinkedIn. I put my link on the Alpha Events website. I wish you a very pleasant evening. Bye-bye.